go out and try this thing. We still got time, you know, it's October. They got 4 or 5 months to really make a real pace car. So he says, well, told the driver, get in with this Mr. Lyons, go take it for a run, and we'll see, then we'll educate him. So Jim Lyons gets in, puts on his helmet, he goes out, gets on in the pits, and they go out in turn 1, and he's putting down the back straight, and he punches it, and he comes out of turn 4, and he started to get it. And they had the clocks on him, and he goes 142 miles an hour past the start-finish line. And then he just kind of lets up a little bit, tapped the brakes a little, down in turn 1, boom, away he went. Like, you know, the thing's really cruising by then. And he made a couple laps, and they come in, and Mr. Finger kind of pulls up and stops, and he just looks at that thing, and he said, he just didn't know what to say. He says, what have you got in this thing? You must have a big block in it or some big block Chevy. They open it up, and it's a Buick V6, and they just couldn't believe it. Well, I think I got to go for a ride in it now. So he gets in it, and he and the race driver took it for a few more laps, and they just couldn't believe it. But the real essence of the car was the Pontiac wanted to say that they had a real production car built down in assembly line in Flint, Michigan, with the regular people that built these cars every day, that it was warranted, it was EPA legal, it was emission legal, and you could drive it on the street with the catalytic converter, the air conditioning, everything, and you could go out and run in front of the race cars. And pretty much that's what we did. So and I'm going to turn it over to Mr. Kelly. And when they got a when they got it in production, that's what you folks drive today.
Oh, so before you go, I'd like you to tell them what's different about the engine. You know, the crankshaft.
Well, there's a lot of differences. It's not a real Grand National Regal. And it was like getting to go behind a real championship team. The people at Buick, which I was a part of in the engine plant, not in the engineering at that time, they built a great engine. You got to remember, back then they were emission controlled. We had, this was the era of a 170 horsepower Corvette. You know, a car that could run even 14.8 seconds was a phenomenon back then. You know, they destroyed all the muscle cars. And they had fuel injection. They had crank trigger ignition. We had a turbo. We had electronic controls. This was like cutting edge stuff at that time. And those folks did a heck of a job. There's no way I could have ever done anything without having all that base in front of me. So, but when I put the front wheel drive heads on this thing, I got some pretty good engineering. We didn't have very good valve stem seals on the engine. And the 86, 87 front wheel drive had those. We had better rocker arms. We had a better PCV system on a Grand National Regal. Sometimes it will suck the oil out of the right hand rocker arm cover up into the turbo, right into the intake. Kaboom, there goes the head gaskets, am I right? You've done that before, huh?
No.
But you know about that. And this one had it already repaired, and it was on the other side. We even had better rocker arm covers. We had better valves. We had better combustion chamber. And that was one of the things, one way we could get this car built, we piggybacked the emissions on top of the Grand National Regal. And the front wheel drive had a smaller combustion chamber, and it upped the compression ratio. We ran quite a few of them. We ran the old white car with the higher compression ratio, and the best 0 to 60 I ever ran was a 4.9 0 to 60. And that was as good as some of the Ferraris at that time. A flat 12 Testarossa Ferrari, we could match them. And Mr. Hulka, sitting in the back here, was the piston engineer, and I knew him. And we figured to make this thing go, we had to, I didn't want to change the head. We couldn't change the head. That's what we were going to get. And we really didn't want to run it at 9-to-1 compression or 9.5, whatever it came out as. So I went down and saw him. He's a good friend of mine. And I asked him, could you deepen the dish and the piston for this thing? Because I'd give him a number of rides in it. We went out, and he likes that stuff too. And he said, yeah, and he did some calculations, and he called me up a couple days later. He said, yeah, we could do it, and this is how we could do it. And I said, well, if we ever do this thing, we get a program, we're going to have to do that, because I don't think we're going to pass emissions, or they don't want to. And so then my management called me in after we got the program, and they says, you know, the Grand National RV6 doesn't have the best warranty. And Pontiac's calling up wanting to know what are we going to do about it to get the warranty down because they don't think it's acceptable. And Mr. Clark over here that worked for the racing department, we've done a lot of oil. They had certain classes they used dry sump oil systems in regular real race cars, but they had some classes where they had to use a wet sump system and they had to use the production front cover with a distributor. And we made them some better oil pumps, and I made them for our production facility. I was over a oil pump functional test where we could actually test the oil pumps before we put them on the engine, which was a great help. And so what we did for him in his department, that we ran them and we sorted them and we got them at the high limit of the pumps, and then we give them to them, and they ran real well. They even ran, you know what the nationwide series is in NASCAR today? Well, it was called Busch back then, and they ran some of those engines in Busch Grand National races with our dry sump, without the dry sump system, with the regular production front covers, and they did pretty good. So I said, well, two things I know. I would hand sort all the oil pumps, and then secondly, I'd cross drill the crank. And he worked for Mr. Clark's friend of mine, and he did a lot of the race stuff. And all the Indy 500 engines and the race Buicks all had cross-drill crankshafts. And they didn't have any trouble. We had some bearing trouble with our Buicks once in a while. And, you know, we'd have more than we wanted. So that's what I told my manager. We're going to cross-drill the crank and we'll sort the pumps. And he said, that's all you do? I said, well, everything else. We got really good head gases. We torque to yield. We got that fixed. We got better head. We got better valves. We got valve stem seals. We got all this stuff for nothing. And also the exhaust manifolds. I knew we had cracking, and I specified a 321 stainless steel instead of 409, which was more expensive, but I knew that would. I didn't know if that would take care of it, but it's the best we knew. And we got all the stuff in there. I says, I don't know what else to do. And we got a piston. We lowered the compression ratio. I says, we don't know anything else except we build out an out racing engine. That's not the scope of this project. They said, well, okay. So that's what they did. And they talked to the crankshaft department, and they said, well, how would we do this? And they said, well, we'll run it halfway down through the crankshaft department. We'll take it out. We took the Buick tool room, which is a beautiful facility with these. At that time, they had state-of-the-art machining facilities, and they were way ahead of anybody race shop at that time. And they cross-drilled every crank. We built 1,500 of them. And then we brought them back, put them in the crank compartment, and then finished them. And those are the things we put in. And Mr. Goad had to do a presentation a year later after we'd sold all these cars to you folks, and they've been out there for a year, and it ended up being the lowest warranty Pontiac Firebird they'd ever made, even though you run them hard. So we must have done it correctly. We had a lot of good help. We had Buick Engineering, we had Buick Racing Department, we had Pontiac. Mr. Goad specified the brakes on these cars are about half again bigger than a regular Trans Am, because he'd road raced and they developed the 1LE package for road racing, and he liked that, so he put the brakes in there, and they put the suspension in from the road racing. So we had all these people kind of doing these type of things, but we didn't have any formal program to do it. So I'm going to turn it over to Mr. Kelly, and then we'll give some concluding remarks.
First time I've seen him in 20 years. Hang on a second, we're going to switch computers.
Which one do you want up first?
Do the production one first. What I'm doing is I saved all the photos of these cars when we built them for all these years, knowing that we're going to probably do this someday. So what I did is I'm putting together a website so you guys can have all these pictures, because they don't show up on here too well. I think I've got 300 pictures total. I took them at Indy, I took them during testing, development, production, and I broke them up into different things. The pilot cars, the other racing thing. I'm going to skip around a lot just because it was, we did so many different things on the car. They're just going to come to me as I go. The racing part of it with Tom Goad is the 1LE package not only was the brakes, but it was your gas tank. And they had a racing series called the Players Series in Canada. And they used all of this stuff on those cars in Canada, so getting them applied to the Turbo Trans Am was pretty easy. And inside the gas tank, there is a baffle. And one of the questions I saw on the website was, why did we change the gas tank? There's a baffle on the gas tank, so when you go around a corner, you won't starve the fuel pump. Whereas the stock Trans Am, if you went around a corner real fast, it would starve the fuel pump and the car would stall. And of course, with road racing, that's not going to work so well. But the other part of that is since we had it in production, we could put it in the race cars. The IMSA Firestone Firehawk series was an endurance series. We'd run 24 hours, 12 hours, 6-hour races all over the country. In 1989, while we were building this car, we took the championship for Pontiac. So this section I've started putting together. It's TTA production, and I can't read squat that says. But anyway, this is the building in City of Industry. We rented this half of it. That car is the third. That's the third pilot car, 213666. That one is now the convertible. And that's the car that I drove in California during production, and when Pontiac snapped their fingers and said, I got to have a car for the press, that's the one that went. It was the show car at Las Vegas and at LA. Next. Oh, that really doesn't show up. Anyway, what I did is I took the pictures that I have and I put them in order of production. So this one shows, what you can see of it is the shipping area of all the parts coming in, because we would build the engine and transmission and the wiring, the intercooler, the turbocharger, all of that was all built on a short assembly line inside of our building, and then we called it a powertrain module. And this is how we inserted our drivetrain into the Pontiac assembly plant and kept the unions happy. This one here, what you can see of it, and keep in mind, all these will be on the website. This yellow tramway here was what we built to build the engines with Buick's input. And I have the process sheets over here I can show you in a little bit. Next. And you can't see it very well, but what we had is we had the engine assembly area in about a quarter of the plant. Behind here was the shipping and receiving, then all the rest of it was for production. This car here, and you can barely see there's a hood behind it, this was a chassis dyno. And every one of your cars came across the chassis dyno, and there's a sun machine. There's a better picture of it, I think, next, but there's a next one. I'll skip around again. This one is this is how your engine and transmission went into the assembly plant as one part number. We built these special pallets. They would stack up. They went over by the truck every couple times a week. But all the wiring harnesses were on it. You can't see them, but the transmission cooling lines are on it. Intercooler is on it. The turbo is on it. But you won't see it in the picture, but what you'll see is the mass air sensor is connected to the inlet of the turbo. And that was, we installed the air cleaner and your flexible tube at our plant, but in order to run it on the chassis dyno and get it on the truck, we put the mass air meter with a jumper wire on it, right on the turbocharger.